Did was a scene where we wanted to sort items by weight. And so, just to quickly review the scene, what we have here is that we have our emitters, and then we have three removers: one, two, and three. And so, what happens is that a package of various shapes and sizes are emitted through the emitter. They come down the entry conveyor and then are loaded onto the weigh station. And so, this red line right here in the middle, that is our at weigh station sensor, which tells the system, hey, the item's over the scale. And then we have a scale underneath there. We also have these black rulers, which are required to send an item forward onto the exit conveyors, which we have the left, forward, and then right exit conveyors. All of this is oriented in the direction of travel. So if we're coming down here, this would be to our left, right, etc. And then there's secondary wheels in there that will shift based off of what direction they need to go. So after the item is weighed, a decision is made and it goes through and it sends it in a particular direction. All right, now looking at our CCW programming. So we've got 4 programs in total. We've got the activation, and what this does is that it activates the loading conveyor, the entry conveyors, the send forward, which is required to move it onto any of the belts, and then the front, left, and right conveyors previously discussed. This here is where when the item comes in, I'm going to go ahead and move this over a little bit. Now when the item comes in, as we talked before, when it senses it at the scale here, it goes ahead and it takes that weight. We do have a latency issue, so when we do our demonstration, you'll see us that we'll go ahead and go pause there. And then once that weight is achieved, then it will go through, and then based off the weight, we'll send it in a specific direction. And you can go ahead and you can see that programming right here. So if the box is between 0 and 3 pounds, it is determined to be small, so it goes to the left. If it's between 3 and 4 pounds, it's a medium size, it goes forward, and then everything else greater than or equal to 4 pounds will be sorted to the right. All right, so the other thing too is that we also have counters in place, so that way we know how many packages are going in each direction. And then that will also confirm if we had a larger system to make sure that nothing was lost in the process, that no boxes went flying off to the sides, etc. And then that way too, we can make sure that we're utilizing properly and that we're not overwhelming one system or another. So later decisions can be made based off of that. All right, so we'll go ahead and we'll go test this out. You can tell that I've already connected it to because of the green highlighting over here. So you can see all of these sensors are already going. So when we press play, you'll see a box will come out. I'll pause over the sensor. So we got weight. You can see here, hey, that just activated. We're at 3.5 pounds. So this should go ahead and send the item forward. And you'll also see, I'm going to pause it right here so you can go ahead and see that the counters have gone up as well. You can see here for the route package that yes, indeed, it will go to the left based off of that weight. And then at the counters, you'll see I will go ahead and I'll stop it here to make sure that that count is. Oh, I missed it. That's okay. Again, we're only pausing due to the latency issues. Again, this one here is just over 3, so this one should continue forward. I'm sorry, it was just under 3. You'll see that counter went up to 1 on the left. So we'll just let it run here for a second. Now, as this is going through, we went ahead and we did our MQTT. We got all that set up. Just go ahead and run these real quick. You can see here that it's already publishing. You can see the counts going up, so you know that it's continuously sending messages. We can also confirm that in the code here, where we're getting these items here publishing, which is helpful. All right, so now that we have everything in the MQTT, what we want to do then is we want to say, okay, hey, I want that information to go up and be stored in a cloud database. And so in this case here, we used render as the cloud, and then we used data group to go ahead and access it. So here's our data group table. You can see that, hey, there's 354 rows, so go ahead and update it. Because of how much that we have to pause this, we do know that the items do change as it goes through. So that having to pause and that latency does cause issues when we're actually looking at the data to say, okay, hey, is it changing? Is it not changing? We do know again that yes, it is. That we know that yes, it is updating because we can see the data changing throughout render when we look at it. Plus the table is updating as well, which is helpful. So, yep. So that's how we know that it's going to the database, and then from the database, you can go ahead and you can see our website or our dashboard built, which will be sent over in a separate video. All right, I'm going to go ahead and stop this here. And then the final piece that we did was the machine learning that we did through RoboFlow. I'm just going to figure out where I put it right here. There we go. So within RoboFlow, we used a screenshot to go ahead and we captured, I believe it was 64 different images, brought it in there, annotated all the data sets. We had 4 different classes. We had specifically the left, did it go to the left, right, forward, or empty to help it identify when the entire conveyor belt set was empty. We did use the YOLO 11 model for that, and actually it did pretty well. You can see here, let me see if I can get up. When we go down, we start to look at, hey, how did we perform? The model performance is actually pretty high. And then we see everything going up here. I have to look into why that it's increasing. The box loss is increasing as the epochs go up. But by and large, it's continuing to decrease or at least stabilizing in terms of object and class loss. Obviously, the more samples we have, the better the model will be over the long run. So then we wanted to go through and test out how everything worked. Because I didn't run the import statement. So this in here, I'm not running everything because I don't want to go ahead and reinitiate the all the screen captures. See here, yep, it's pulling. This one here, it struggled a little bit. And then you can see the count objects, I believe it was 170 some odd, which was really quite high. Give it a second to keep loading. And this time we got 166. So, all right, so let's go ahead and let's test it out. Deprecation warning, that's fine. We're inputting our image, our results. And then here is some random photo to see how it did. So it actually did pretty good and identified things correctly. So items that are on the actual sorting and had not yet been confirmed as sorted, we didn't want to count. So if it's in this gray area, we didn't count it. And then it correctly identified the empty belts and then the one package that went to the right. All right, so I did take a short video earlier to go ahead and say, hey, would this be doable on a live stream? We'll give that a second to start. You can see here the screen recording started. And again, it's identified all the conveyor belts as empty. And I'll start here in just a moment. So this one here correctly identified right, and that conveyor belt was no longer considered empty. Waiting for the next box to come through. It did seem to struggle a little bit with initially categorizing these ones as forward, even though none were annotated as forward. And there we go. And then again, once it's empty, it is correctly categorizing it as empty. Yep, so that concludes our presentation, and thank you so much for your time and your patience with us.